Good morning, dear students. My name is Ferhan Mazher, and the subject we are studying is Pure Maths 1, and we are working on the chapter number 8, which is further differentiation. In this chapter, we are right now working on the exercise 8E, and in this episode, this is our fifth episode on this chapter. We are going to work on the question number question number 10, and it says the diagram shows a right circular cone with a radius of 10 centimeter and height 30 centimeter. The cone is initially completely filled with the water. Water leaks out of the cone through a small hole at the vertex at a rate of 4 centimeter cube per second. Show that the volume of the water in the cone V centimeter cube when the height of the water is 8 centimeter is given by the formula V is equals to pi h cube divided by 27. Find the rate of change of the h when the h is equals to 20. So we are going to attempt the question number 10 and let's start this one. Okay, so here we have a cone. So what we are going to do is we are going to, first of all, we have to show the volume. Okay, so this is that diagram. Okay, so this is the question number. Basically, we are working on the question number. This is our question number 10 of the exercise 8E, Pure Maths 1. And so let's start. And it says that here we have a cone is shown to us. Okay, so I am going to make this is when the cone is full, and this is the level of the water. Suppose when the height is h. Okay, so this is 10, this full height is 30, this full height is how much? That is 30 centimeter. This is 10 centimeter. Okay, so this height is suppose h, this height is h, and this, let me say, this is r. Okay, so because these two triangles, they are similar to each other, this angle is common, this is 90, this is 90. So this small triangle and this big triangle, they both are similar to each other. So the ratio of the radius to the radius and the height to the height, that will be similar. Okay, because the ratio of the corresponding sides in the similar triangle is same. So I can say that the r will be equals to the 10h by the 30. So the r value will be equals to h by 3. So now the volume of that water, we are talking about this diagram. So the volume here, the volume of the water right now, it will be in the cone, the volume, the formula for the volume is 1 by 3 pi r square h. The volume will be equals to 1 by 3 the pi. The radius is h by the 3 and its square and into the height. Okay, so the volume will be equals to this will become 9 3s are 27, so it will be pi h cube divided by 27. And that was the first part of this question. You see, question number 10, it's a part. This is what they have asked us to show, and we have shown it. Now the b part, we have to find the rate of the change of the h when the h is equals to 20. The dv by the d, they have given us that the dv by the dt is equals to, that is given in the question, that is 4 centimeter cube per second. Their question is find the dh by the dt, the rate of the change of the height, and that is our question. And when the h is equals to 20, when h is equals to 20, okay, so it will be centimeter. So you see, I know this formula for the volume. I can derivate it. Okay, so the v is equals to pi by 27 and h cube. So dv by the dh will be equals to it will become pi 27. 3 will come on the side. The power of the h will be decreased by 1. So you will have dv by the dh, and that will be equals to 3 and 27 will be cancelled. So pi h square by 9. So when the h is equals to 20, so you will have dv by the dh equals to pi. In the place of h, I will substitute 20, its square divided by the 9. So you will have dv by the dh equals to 20 square will be 400, and you will have pi divided by 9. So then because I want to find out the dh by the dt, I will apply the chain rule. Dh by the dt will be equals to the we will have you will have dv by the dt into reciprocated dh by the dv. Okay, dv will be cancelled, so you will get dh by dt. So this is my chain rule. So the dh by the dt will be equals to, you know, the dv by dt, its value is 4. Okay, the dh by dv, you reciprocate this thing, so 9 divided by 400 pi. So my dh by the dt value will be equals to 4, and this will be cancelled, so you will have 100 pi. This will be centimeter per second. So with the help of the calculator, I can convert this into decimals. Let me check if they have given the answer in the decimals. If they have given an answer in the decimals, we will also convert this. And so it's so you can see exercise 8e, question number 10. Its answer is 9 by 100 by centimeter per second. With the answer, they have written negative because, you know, this rate was negative. Why this was negative? Because it is leaking out. So your answer will have also a negative sign. So this is how you can do the question number. Let me bring it near. So okay, so this is how this question is done. So this is question number 10 of the exercise 8e. This is our 5th episode on this exercise. Okay, so let's go to the next question of this exercise. Let me show you the question. The question number is showing up on your screen. Here we have the question number 9. Oil is poured onto a flat surface and a circular patch is formed. The radius of the patch increases at a rate of 2 under root r centimeter per second. So dr by dt value is given. Find the rate at which the area is increasing when the circumference is 8 pi centimeter. Okay, you know, it's simple. So let me do that question, sir. This is the exercise. This I am working on the, this is going to be the question number. This is question number, I'm working on the question number 11, and this is our 5th episode on this exercise, and the exercise is 8e from the pure math 1. Okay, so let's do this question number 11. Oil is poured onto a flat surface and a circular patch is formed. The radius of the patch increases. Okay, so basically they are talking about a circle. So the dr by the dt is given. The radius is increasing at a rate of 2 under root r centimeter per second. Okay, he says find the rate at which the area is increasing. Okay, you know the area is pi r square. So their question is dA by the dt is question, and they say when the circumference is equals to, they have given me 8 pi centimeter. Okay, from, you know, the circumference is 2 pi r, which is equals to the 8 pi. From here I can find the value of the r, which is 4 centimeter. So the dr by the dt when the r is equals to 4, that will be 2 under root 4. So the dr by the dt when the this becomes 2 into 2, so the dr by the dt will actually become 4 centimeter per second. Okay, now I know the formula for the area. The area is given by the formula, pi r square. Okay, so I can find dA by the dr. Okay, so that is pi into the 2 into the r. Power will be decreased by 1. So when the I know that the r value is equals to 4, so the dA by the dr will become pi into 2 into the 4. So the dA by the dr will be 8 pi. Okay, now because I want to find out the value of the dA by the dt, I will apply the chain rule. dA by the dt, that will be equals to the dA by the dr into the dr by the dt. Okay, this and this will be cancelled. You get dA by dt. So dA by the dt, the value of the dA by the dr is equals to the 8 pi. Okay, and the value of the dr by dt, we know when the r is equals to 4, is this is also 4. So this becomes 16 pi. So your dA by the dt, that is equals to the 16 and pi and the centimeter square divided by second. So that is 16 centimeter square per, I don't know, let me check the answer, sir. So this is how you will do your question number 11. So let's check, sir. Let's check. So we will check question number 11. Their answer, oh sorry, this is not 16. 8 fours are 32. So your dA by the dt, sorry, I multiplied. 8 fours are 32, sorry sir. Pi centimeter square per second. So your answer, exercise 8E, you can see exercise 8E, question number 11, 32 pi centimeter square per second. So this is how you will do the question number 11. So let's do the next.